Okay, so this section is on using tangent ratio to find missing lengths in a right triangle. And we basically start these problems off the same way that we solve to find missing angles. We determine which sides of a right triangle are the opposite and adjacent hypotenuse, set up your tan ratio, and then solve your resulting equation. You again have to make sure that your calculator is in degree mode. Okay, so let's try a few examples here. So, first one there, we have to determine the measure of the side marked x. So if we look at the information that we have, we're given an angle, 65 degrees. We are asked to find the side which is considered opposite that angle, and we have the side that is adjacent to that angle. We do not have the hypotenuse. So the information that we have, opposite and adjacent, is enough to use the tan ratio. So we set up the equation using tan. We have tan of 65 would be opposite, which in this case is x, over adjacent, which is 30. Now, this time we have the angle, so what we're going to do here is we're going to basically consider this as tan of 65 over 1 equals x over 30, and then we can cross multiply because you have a fraction, a single fraction equal to a single fraction. So basically you can cross multiply and get a resulting true equation. Or you can consider this as isolating the x if you want. You can multiply both sides by 30 to get rid of the fraction on the right hand side. Either way, you're going to end up with x times 1 equals 30 times the tan of 65. And then it's just using your calculator. You actually just punch into your calculator 30 times the tan of 65. When you're putting this into your calculator, some calculators you will have to put the 65 degrees in first and then hit the tan button. Some calculators you'll have to hit the tan button first and then hit 65 degrees. So you should get the same answer as I'm getting. If you're not, you're doing something wrong. You can check with me if you're not sure how to figure it out, how to do it. So tan of 65 times 30 is going to be 64.335, and that gives you about 64. Is there a side length? We don't know the units, so you can just leave it like that. The next one, if you look at the information that you have, you're given this angle here. You do not know the side opposite again, but you do have the adjacent side to that angle. So again, we can use tan, set it up. Tan of the angle 54 degrees is equal to opposite, which is x again, over adjacent, which is 25. Again, we can write this over 1 and cross multiply. So basically, if you're looking for the angle, you use inverse trig. If you're looking for the side, you cross multiply. Set it up and cross multiply. So this becomes x times 1 is x equals 25 times the tan of 54. And again, you should be careful putting using your calculator. Make sure you know how to use your calculator properly. If you put in the 25, if you hit the tan of 54 first and then 25 after, if you're not doing it properly, you might actually be finding the tan of 54 times 25 degrees, and that's not what you want. You want the tan of 54 degrees. Get your answer and multiply it by 25. So make sure you're putting it into your calculator properly, or using brackets properly. Some calculators automatically put an open bracket, and if you don't put the 25 in the right place, you might actually be finding the angle that you're using might actually be 54 times 25 degrees and not just 54 degrees. So you should get the same answer I'm getting. So 25 times the tan of 54, and I got to close my bracket around 54, and I get 34.4 around there, and that would be, if I round it off to the nearest unit, would be 34 units. Okay, so that's it for that example. The next one is at the top of the page here, page 34, and again, if we look and label our triangle to see what sides we have, this time we have the opposite. but we don't have the adjacent side, the side that's making up the angle. So we would still be able to use tan though, because there's still only one thing we don't know, and we can set up tan of the angle 63 degrees should be opposite, which is 50, over adjacent, which is x. So this time it's a little bit different because the x is in the denominator. We can still cross multiply, or multiply both sides by x if you don't want to cross multiply. And you're going to get x times the tan of 63 this time equals 50 times 1. So if we want to get x by itself, we would like to get rid of that tan of 63. So we're going to divide both sides of the equation by tan 63. So then we would have x by itself on the left hand side. So that would equal x equals, because they're going to cancel, x equals 50 divided by tan of 63. And if you punch that in your calculator, you should get 25.476 approximately. So that's approximately 25 to the nearest unit. The next example, we have x is again adjacent to the angle that we were given, and we have the side opposite that angle. So if we set this up, we would have tan of 41 is 35, opposite over adjacent is x. And again, we set it up to cross multiply. We get x tan 41 equals 35 times 1, which is just 35. So then we have x tan 41 divided by tan 41. So we're dividing the tan 41 out of both sides so that we get x by itself. And x is equal to 35 divided by tan 41. And we get 40.262, so on. So that would be approximately 40 units. Okay, so the next example asks you to find and correct the error in the following calculation. And it says, how do you know that x equals 3.64 must be incorrect? So if we look at the example that we have a right triangle, we do have an angle of reference of 20, and they are using the tan ratio. But when you set up the tan ratio for this angle of 20, the opposite is actually 10, and the adjacent is your x. But this person has mixed those up and has x over 10 when it should actually be tan of 20 is 10 is the opposite over x is the adjacent. So this one here would be solving kind of like the ones we just did last. When you cross multiply, you would not get what they have here because this is incorrect. You would have x times 20, tan 20, sorry, is 10. And then you can isolate the x by dividing both sides by tan of 20. And that will give you x is approximately 27.474, so approximately, rounding to 2 decimal places, it would be 27.47. Now it is possible that you, if you wanted to use your tan ratio where the x was in the numerator instead of the denominator, because when you have it in the denominator there's a little couple extra steps there. You could actually switch if you want, this angle here is 20. If this is the x and this is 10 and you didn't want to have 10 over x, you could actually switch to this angle, which would just be 180 degrees. Take off the 90 degree angle, take off the 20 degree angle, so what's left would be 70. So the other correction that would be acceptable for this particular problem would be to say, instead of 20, if they wanted to use the x over 10 ratio, they could have said tan of 70 is x over 10, not tan of 20. Then the x would be in the top, and it would be just cross multiplying, you would get x is 10 times tan of 70, which should give you the same answer as doing it the way we just finished doing it, because they're both representing the same side. So tan of 70 times your 10, which still gives you 27.47. Okay, so either one of those would be okay for that. Our next example is a little bit of a word problem, I guess. So it said a wheelchair ramp on a bus forms an angle of 18 degrees with the ground. If the floor of the bus is 65 centimeters above the ground, how much width does the ramp require beside the bus? So you have a wheelchair ramp, you have the bus, the floor of the bus is 65 centimeters above the ground, so this is 65. And then you have that the wheelchair ramp makes an angle of 18 degrees with the ground. So that would mean, if this is your ramp right here, this would have to be 18 degrees. There's the ramp, there's the ground. So it says, how much width does the ramp require beside the bus? So basically you're looking for this. How much space do you need here between the end of the ramp and your bus? So this again would be a right triangle, because this would be a vertical line and a horizontal line. So you can again set up your angle 18 would have the side opposite is known, but the side that's adjacent to it is not. So again, that's a tan information. So tan of the angle 18 should be 65. Opposite over adjacent would be x. And we can cross multiply here and get x times the tan of 18 is 65 times 1, which is 65, and x tan 18, divide out the tan 18, and we get x is 65, tan 8 divided by tan 18, which is about 200.049 is on my calculator, so 0.05 centimeters. So approximately 200 centimeters if you wanted to round it off to the nearest centimeter. So example 4 says a housing contractor is required to build a roof on a house with a 38-degree slope from the horizontal. Additionally, the peak of the roof is to align with the center of the end walls. The house is 16 meters wide and has end walls that are 4 meters high. To the nearest tenth of a meter, how high will the peak be above the ground once the house is complete? So the first thing we need to do is kind of fill the information they're given into our diagram. So it says that the roof is a 38-degree slope from the horizontal. So the horizontal would be measured from here to here. So the 38-degree slope would be this little angle in here. Right there. And it tells you that the peak of the roof is to align with the center of the end wall. So this would be your end wall here. This part down here. And so that looks like the peak of the roof is lined up with the center of the end wall. It says the house is 16 meters wide, so the end wall would be 16 meters wide this way and 4 meters high. And if this is 16, then this here should be 16 meters. And we're asked, to the nearest tenth of a meter, how high will the peak be above ground once the house is complete? So the easiest thing to do here would probably be to draw a right triangle from the peak of the roof down here. And then we know that the piece that we have, this little piece here, we could add it to 4 meters to get how high off the ground that peak will be. So if we look at the little right triangle that we have, and I'm just going to draw it again here because it's a bit squishy there, it's hard to read it. So this here would have to be x, we don't know what that is yet. We do know that this is 38 degrees right here. And if this peak is halfway or in the center of the end wall, that means the end wall being 16 meters, this should only be 8 because it's halfway. So again, we have a right triangle where we're looking for the side opposite the angle that we know, and we have the side adjacent to the angle that we know. So we can set up the tan ratio again. Tan of the angle of 38 degrees is equal to the opposite, which is x, over the adjacent, which is 8. And if we cross multiply, we get that x times 1, or x, is equal to 8 tan 38. And when we calculate that, we get 6.25 approximately meters. So therefore, the height of the peak from the ground will be your 6.25 meters plus your 4 meters that it's right here. You're going to add the 6.25 to this height of 4 right here, and that should give you 10.25 meters above the ground. Example 5, Mr. Reddick's design class is required to build model cars. The models are tested for efficiency by releasing them at the top of a ramp and comparing the distances they travel. The ramp extends over a horizontal distance of 375 centimeters and forms an angle of 38 degrees with the floor. Calculate the height of the ramp. So this would be extending 375 centimeters horizontally, and it makes an angle of 38 degrees. There's the ramp and the floor would be 38 degrees, and you're looking for the height of your ramp. So again, according to the angle that we have, in reference to the angle that we have, we need the opposite side, and we have the adjacent side. So therefore we can use tan again. Tan of 38 degrees is opposite over adjacent is 375, and then again, if we cross multiply, we have height equals 375 times the tan of 38, which if we calculate is 292.98. So to the nearest centimeter, that would be approximately, to the nearest centimeter would be 293 centimeters, so approximately. Example 6. A boat is 102 meters away from a lighthouse. A person on the boats sees the top of the lighthouse at an angle of elevation of 15 degrees. And if you remember from a couple of pages ago, we talked about angle of elevation is measured from where you are. You draw a horizontal and measure up from that horizontal. So if you're on the boat, your horizontal would be this line here, basically, with the water. Okay, and so you're measuring up from that, so that would be 15 degrees. And the boat is 102 meters away from the lighthouse, so you're assuming that that means horizontal distance, 102 meters away from the lighthouse. And it says, how tall is the lighthouse, assuming the base of the lighthouse is at the same height as the ocean? So again, it would be a right triangle configuration here because this would be considered a vertical, this would be a horizontal, so you'd have a right angle. So again, the angle, in reference to the angle of 15, the x would be the opposite side, and the 102 would be the adjacent side. So we would set up the tan ratio again. Tan of 15 degrees is equal to opposite over adjacent. And then we can put that over 1 and cross multiply and get x is equal to x times 1 is equal to 102 times the tan of 15, which would be 27.3 meters, is it? Approximately 27.3 meters. And it doesn't say how to round it off to the nearest meter, so you can leave it at 1 decimal place. So that's the end of that section. So you can try some of the questions on pages 82 and 83 in your text to practice that material.